Hey everybody, this problem is similar to a problem I did earlier, which attracted a lot more attention than I thought it would. Now let's simplify it just a little bit. Let's just take a look at log base 11 of x equals to 2. And this is just a real standard college algebra, I guess, equation. Now it's clear just by the definition of logarithms that x has to equal to 11 squared. Okay. And x is just an arbitrary input to the logarithm function. And of course 11 squared is equal to 121. Okay. Now our input happens to involve a summation with an unknown upper limit, I will call it. So let's make a little bit of progress on that. And I did this earlier in the other video, but let's just do a concrete example. Let's say we have summation. We'll do the lower limit. We'll call it 8, let's say. I equals 8. I equals 8, and we'll just set the upper limit or upper index to 10. Okay, again, all we're doing, the summand is just a constant 1, so we're just adding up ones. So this would be equal to 1 plus 1, okay, plus 1. And again, the thing that bothers some, myself included, is that you see there's nothing that depends on I in the summand. There's just a constant value of 1 here. So this definitely corresponds to the index 8. The first one does. The second one corresponds to the index 9. And the third summand corresponds to the index 10. And of course this sum is 3. But notice that that is equal to, I'm calling it the upper index. Whether that's correct or not, I don't know. But that's equal to the upper index minus the lower index plus 1, right? And it may be slightly helpful to put this parenthetically, envelop it in parentheses. 10 minus 8 plus 1 is 3, right? And so this is just a single case justification for this more general truth. You could prove this by probably induction if you wanted to, but I don't think we should go to that much trouble. Okay, it's clear this is the kind of thing that would happen any pair of integers like this, any pair of positive integers. Now, so how does that help us? All right, well, we already know from our earlier work that this summation inside of here must equal to 121, right? So that's why I wrote this down. I just wrote down what we observed at the very beginning of the problem. But we also know that 121 must equal to k minus 33 plus 1. Okay, and that's from this result right up here. Now, however you want to do your arithmetic, but that's equivalent to 120 is equal to k minus 33, which certainly implies that k has to be 153, the natural number 153. Okay, so again, the final answer here would be 153 equals to k. And that's it, folks. Again, kind of a fun little problem because it's not particularly difficult. I think it's just more a matter of notational fluency. And also this part about adding the ones, slightly sneaky, but it's kind of the same thing that happens when you're doing combinations, factorial type expressions. You have one extra term in there. It's not just the difference of the upper index and lower index. It's that difference plus 1. Anyway, that's the final solution, folks. Let me write it up here. K is equal to 153. Thanks for viewing.